Okay, so here's the answer for question 6 for the motion and forces review questions. Right, so we've got a graph that looks something like this. Okay, so we start here at 2 and go up to 4 in 2 seconds. And then we've got a flat bit up to 4 seconds, and then to 7 seconds we go down, crossing at 6. Okay, and end up -2 here. Right, so the task here is to find the area under the graph to get the displacement. So we'll section this off into these sections. And finally, I'll just fix this one up a little bit here. Whoops. Just want to get that. So it can be about there for the 7 seconds. Okay, so total displacement here. Yes, with the squiggle. Okay, so this area here is 2 by 2, which gives 4. Here we've got a triangle, so it's a half times the base 2 times the height 2, which gives 2. So this of course is all in meters. Here we've got the velocity in meters per second versus time in seconds. Okay, so 4 meters and 2 meters. Here we've got a 4 by 4. Sorry, not a 4 by 4, a 2 by 4. So 8 meters in that one. Here we've got a half by 2 by 4, which gives 4 meters. And finally down here, we've got a half times 1 by 2, which gives 1 meter. Now, so we add these all up for the displacement, 4 plus 2 plus 8 plus 4, except here we've got an area that's below the graph, so we're going to subtract that one. That's going to be -1. So what do we get there? 6, 14, 18, and take 1, 17 meters. And I suppose with the direction, we can just say forwards. Oh, don't know what's going on, sorry. Bear with me here. Okay. 17 meters forwards. Right. Now that's the answer for part A. Now in part B we just want distance. So I'll just put an S without the squiggle, and in that one we just add everything. We don't worry about areas that are below. So I suppose that gives us 19, does it? Just check that. 6, 14, 18, 19 meters with no direction required. Okay, so average velocity and average speed over this time. Okay, so average velocity is displacement over time, and speed is distance over time. So for the velocity it's 17 over the 7 seconds, and for speed 19 over the 7 seconds. Okay, what does that give us? 2.43 meters per second forwards, and 2.71 meters per second for speed. Okay, so part D, we need to sketch an acceleration time graph. So the slope or the gradient of the velocity time graph will give us the acceleration during each section. So from 0 to 2 seconds, we have a rise of 2 over a run of 2, which gives us 1. From 2 to 4 seconds, 0 meters per second, because the gradient is 0. So no calculation really necessary there. And from that last section of the graph, 4 to 7, we have a rise of -6 during 3 seconds. So -2 meters per second squared forwards, or 2 meters per second squared backwards. Okay, I'm running out of room a bit here, so I'll rub out some of that stuff just above. You should have noted that down, or you can just rewind the video and have another look at that. Okay, so to get our graph, going to need some negative to this, so I'll put it like this. Okay, so we've got time in seconds and acceleration, meters per second squared. Okay, so for the first section from 0 to 2 seconds, we have an acceleration of 1 meter per second squared. So horizontal line there at 1. Then we're at 0 from 2 to 4 seconds. So like that. And then from 4 up to 7 seconds, we're at -2. So roughly double in the other direction, -2. So something like that. Join up the discontinuities like with a dotted line, and there's our sketch for the acceleration time graph. Okay, move on to the next one.